Hi everyone, thanks for coming. I'd like to introduce you to John, as you haven't met him. Has anyone met John before at all? We met John several years ago when he came on one of our fitting courses. And little did we know he was a biomechanist at the time. Actually, I've got to get in the camera. John, come into the camera. Sorry. Is that okay? And since then we've worked with him, and he's been a big influence on the way we look at fitting and the way we approach our fits, and also on anything to do with cycling. He approaches everything from a slightly different angle than what's normal, whether that's a good or a bad thing, but if we do work with him, it really does stimulate us. So hopefully he'll do the same with you guys tonight, and we want to go away with some little gem of information. So, John Iriberri, thank you.
Okay, thank you very much for coming, attending. Thank you also obviously to Cyclefit. Cyclefit is very important for John Iriberri, has been important in the past, it's very important today, and will be very important also in the future for me. It's much more than a professional relation, it's something quite eclectic. For me, Cyclefit is always a very good plan. I have prepared one presentation. I think that can be very dynamic, very interesting from my point of view, and I have tried to transmit my interest in several things to all of you. I have been talking about some of the things that probably you know around cycling from a biomechanic point of view several times, and performance point of view. That is my day-to-day job. And I try to present a different point of view. Time ago I'm thinking about our social responsibility. When people as me, we talk about the things, we should take care a little bit what we are talking about, because several times a lot of people is looking for us, they are doing what we said, and if I am wrong, maybe a lot of people is getting some mistakes, some injuries about my recommendations and my advisement. So I have been in the past very critical, but I am today much more critical with myself and with the people that is around me. And okay, let's see what happens with this, the logical fallacies. I will try to explain what is a logical fallacy for those that they are not very focused and not very maybe forming on that, but from the perspective of cycling. So, okay, this is one image that explains me or explains more or less who is John Iriberri, the way of thinking, and a little bit probably some of the mistakes that I do every day, they are related with this image. So I try to demonstrate some things. I'm very hard on my behavior, on my job. Several times I try to going on with things that they don't come on, but I admit myself like I am, so I love myself a lot. And I don't have any kind of problem to admit that this is my behavior. I suppose people that knows me here in Cyclefit agree totally with this photograph as representative of John Iriberri. Okay, maybe in the last time I have been more maybe public than before, but things like that I appearing on this image, so things that normally doesn't come on with the normal social rules. I do things that they are not expected sometimes, and this came a lot of attention to me. Several times makes love, other times maybe doesn't take love. It's another kind of operation of the people, but I am like I am, and I don't think I am going to change a lot in the future. I love a lot any kind of challenges to try to, what is difficult is interesting for me, what is easy maybe is not as interesting for me. So we tried to put it on one girl of 6-7 years old in a 32 inches bicycle, but it's basically impossible. I think that it makes also a good idea or representation of who is Iriberri, or my way of thinking about several things. I cannot explain really why I became in fitter and not in any other kind of job. Maybe I like to help to the people, and if these people is like in the image something that can be interested in different and several different ways, social ways, but my interest it can become higher and higher. Cyclefit, as said, has been very important for me. This is a quite tall image. I was coming here to trying to sharing the knowledge with them. This was Sandy Kuhn, that on the past was a professional rider, was involved also in fitting here in Cyclefit, and we did several things that I think that were important for me, professionally and personally too. Some of the things that I do, they are quite polemic sometimes. This is one of the maybe most known cases, because I developed one design of one saddle that obviously is quite related with maybe social matters that I don't take care of, but other people maybe is more interested than me on that, and they look the same problem from another point of view. So what happens normally that who see this kind of things, normally the normal reaction is not the reaction of the fitter or the fitting world or biomechanic involved, somebody's something a little bit more strange. But I know the people is, I don't know, they take care of me and they do what I say, and it's nice, funny. Going on with things that I do normally, that they are out of the market, out of the industry, I got a big imagination. I think I can do things, and I'm very happy about that normal people cannot do. You can have the imagination, but then you come to become in real situation. So related with the first image, I'm very focused on when I'm going on something, and I get things that probably they are not very useful for a lot of public, but I can do them, and it's one of my public image related with that. I can do things that other people they cannot do. Okay, this one maybe I have to. There is one video, for example, another thing that I do that is maybe more interesting than all the other things. This is one wheel that can return the inners of the wheel, that's a flying wheel, to the cranks. This one prototype that we developed and makes returning for the wheel the power, so it helps on the riding of the cyclist. We are working 1 year on that project, quite successful. I think that it will be very interesting in the future to see how these wheels works, because they save a lot of energy from cyclists. Another way, I got quite normal problems with my family, with my wife, that probably a lot of you have led the same situation sometimes. And let's talk about what's a logical fallacy. To believe in something that based on the faith and the emotional reasons rather than the intellectual reasons. So in the example, if two negatives make a positive, how can two wrongs don't make a right? So it's one example. There are several different examples about what is a logical fallacy. It seems that it's true, but maybe it's not true. Some recommendations that I several times do about cycling science bibliography. One book about why people believe in weird things. Obviously it's not related with cycling, but explains a lot of things that I'm going to try to translate to you this night. And a critical reading article that I use basically, once I read, I try to see what I read from a critical point of view. To be critical must be also like a system, like a systematic of reading, basically for don't believe in weird things. I will start with one of my myths. Some of the, I mean my myths, maybe it's not the selected myths from the point of view of the conference, and I will try to offer. Has the pro cycling power improved or decreased in the last 15 years? A lot of people today is speaking about this in the internet today, that the power meters are used by professional riders in the Aero race. There is a lot of maybe noise more than information about they are better, they are worse, maybe they are improving or they are not now, but the training is better now than before. Yeah, okay. A lot of things that happen is related with the doping on the cycling tour on the past. So we did one job related with this during the last 5 years, and okay, to see what has happened. This is one work what we presented on the past about the power made by the cyclist over the time in the 2006 year. So the records of power depending on the time. This is called the power profile, and it's quite often today with trainers, riders. A lot of people is involved on that right now because a lot of people is involved in power training. So we measured all the records each time. We got here the minutes, and for example, there was an example here of the record of the maximal sustained power in 6 hours riding, near to 4.6 watts per kilogram. So what thing that is today's historic, but not on the 2006. We compared them statistically to see from 2000 to 2008 and before the 2000, and from 2008 to 2012 to see if there has been any change on those numbers, on those records. And we decided to choose them because before the 2000 year there was no EPO test, so was no risk of, from the point of view of being banned, I mean, of taking this drug. On the 2000 it starts the EPO test, and 2008 we take another stop because it's starting the biological passport. That's another way of controlling the blood values of the riders over the time. So we did like 3 parts of the evolution and checked them. Maybe this is not very useful, but then on this graph you can see the red values before the 2000 year, the green one on the medium, and the blue one, the last data that can be actual data more or less, will not change. And you see that in different time exposures, the power is lower today and was lower on 2000 to 2008 than related to before. From a skeptic, very skeptic and very polite point of view, maybe one or some factors has made increase the power in pro cycling in the last 15 years in a significant way. I mean, based in this data, we can make a lot of hypotheses what has happened during the last year, because everything has improved, the technology has improved, the training has improved, the records are for being baited, but the performance is going down in 15 years. So it's not an anecdotic phenomenon, it's quite long over the time, so something has happened. If I will not be a very skeptic person, I would say it's because of, but I has been becoming in a more skeptic about the things, and I can demonstrate that has happened, but I cannot have any idea why it has happened. So I cannot give a concrete answer. I only have demonstrate that there is a lower risk value every time statistically. But why? It depends. Another thing that maybe can be...
John, if you're saying power has decreased over the last 15 years, nutrition is better, training is better, everything is better, how can you must provide some kind of possible solution to why the power's gone down.
That's to make a new hypothesis and try to demonstrate it.
Pardon?
Try to demonstrate it after you making a new hypothesis. From this safety point of view, you cannot say, I think that the reason is, okay, it's your opinion, but that's not science.
But what's your opinion?
My personal opinion.
Well, if you present data that says that power has gone down over 15 years, and then in the same sentence you say, training's better, nutrition's better, everything's better, but power's gone down, you must have a personal hypothesis.
In our mind, it's obviously the use of the drugs. Yes, I have not demonstrated. I cannot say that. That could be the first hypothesis for a new scientific.
Is there a viable, is there a rational other alternative?
Yeah, but when it's rational, it doesn't make sense sometimes. That's a logical fallacy. Another thing that I think that somewhere it's in our mind how to get in a little bit like stronger, a little bit less of mass and losing. I think that's not only an interesting issue from the point of view of cycling. I think that's a social issue that people tries to get in a very slim and fitted way. And obviously, the marketing industry is providing us a lot of things to try to be a little bit fitted. What's telling the science about this? So Jürgen Drew, that is an international authority about that. The decreasing factor, how to burn more and more fat during the training. So what makes the decrease to use the fats and burn them during the training? For example, to carbohydrates in diet. When I take every day carbohydrates in my diet, I am decreasing the use of the fats when I am training. So it's an inverse process. The carbohydrates in the intake before the exercise also doesn't make sense from the point of view of burn more fat during the training. The hot environment and the altitude. So those are things that we have to avoid if we want to burn more fat during one training. This is a graphic that demonstrates after the ETs, our intake of carbohydrates has been improving and improving. Maybe some of you cannot see the difference, but this is an epidemiology study, so the society in general is taking much more carbohydrates than the last 13 years. The things that can increase and decrease the burning of the fat can be the intensity of the training. The more intensity, the more you are going to burn on the training. These are the crossover concept that is called. So the more percentage of aerobic power, it means that you are going to burn more energy. Sometimes this fat is going to be lower, and it's arriving to one point around the 60%. Around 60% is quite individual, but can be quite generic. In the 60% of my maximal aerobic power, it's the maximum amount or quantity of fat that I can burn in relation with the carbohydrates that I burn too, because I burn both at the same time, so I have to balance them, and this is what science says. The increasing factors, my performance levels, the best performance levels, they burn more fat, the duration of the training, and something quite characteristic, the intermittent hypoxia. So the recommendation is quite easy: eat clean, train hard, and repeat again. So this is a not very funny story, because people want to take something to get slimmer, easy, not very, it's possible, not very hard to going on with that. But the bad news is that nothing has changed in the last 20 years around that. So everything that you are taking to try into this product, this other one, or maybe. Okay, one other myth is the saddle cutout the hole that is in some of the saddles that became very famous in the late 90s or 2000 around, was starting before there was not hole on the saddle. Today is like one decision that we take. We want to buy a new saddle and we check if this hold it or not hold it, so it's called a put out of the saddle. And the Fibre of that started on 2002 when a very important journal in the States published the relationship between the erectile dysfunction and the cycling in general. So it became in a fever about this because obviously a lot of people was cycling and they think that there were moments that they were in risk of doing that. And it was a lot of noise about this article. Goldstein became a very important person because he was the advisor of this new religion that cycling was more or less bad. Because you can read on the title, it's a question that he does on the article, was like opening the bomb, but he's not justifying that was bad or it was good, only was okay, maybe it's an hypothesis because it was not demonstrated is one, but the people get a lot of scared. This became in a lot of marketing noise from the point of view that people became in doing all the effort to demonstrate that they saddles were good for the erectile dysfunction. Sometimes was the hole, sometimes was the, I don't know, the geometry of my saddle. A lot of noise, lack of science. What science says is, does bicycle contribute to erectile dysfunction? Examining the evidence, taking all the science available today, representative science, the cyclist should choose a saddle that allows him her to put most of their stated weight on their ischial curiosities. Saddles with perineal cutout are not necessarily protective, and multiple studies suggest that these saddles might be detrimental. So that's a logical fallacy. They make scared. We became in, take a look about my saddle. It's good saddle, it's not good saddle. That you go for any kind of bad sensations. No, but for prevention, maybe withhold better. Because of prevention, no, that is not science. Science says that this is no prevention. Sometimes also, maybe it is worse than the regular one, what science says. This is a meta-analysis. A meta-analysis is all the available science together about one matter. That's a meta-analysis. So it's the biggest form of knowledge that we got on science. I have one question related with the wheels. We obviously change of issue and myth. Maybe some of you you got the opportunity of changing the wheels. You have made this exercise. You got the high profile wheels, in this case the famous lightweight wheels, and one alloy rims, normal, the traditional one, 32 crosses and nothing new under the sun. So those are the classic wheels and those are the aerodynamic wheels at the end of the day. The cost of those are 300, 400 maximum pounds. Those are can right to be between 2,000, 4,000, around that pounds, more or less. We check 40 kilometers per hour on the same bicycle. How many seconds can save the wheels to those other ones? Has anybody an idea of that? But all of you have seen those wheels, and probably some of you love those wheels. But you don't know how many seconds you save on 1 kilometer compared with the cheapest one. When you see to the marketing, and say, put it on this helmet, 2 seconds less. Put it on this saddle, I don't know. Put it on these wheels, put it on this frame, put it on this cover for the shoes, put it on all of those things, and you are going to save, maybe you are going to do in the minute in less than 60 seconds, but it's physically impossible. So, all of those research are sponsored research. So to believe on them is quite tricky because normally they don't tell the truth. The most, they are not telling lies neither, so it's quite, they move in a quite interesting place. When, for example, it's only when they check one helmet, for example, they put it on one head, plastic head, and they put it on the helmet, on that. What happens that all the advantages doesn't make the sum of the advantages because they make interference between them. So when you take the difference, or you take the seconds that you are going to save over the time during the minute, it makes you an irreal quantity of advantage. So you are, no, I will, today I will take my wheels, I will take my frame because this kind of, I want to save 3, 4, 5 seconds, I don't know. And then the helmet, and then I think that a lot of people, maybe related with triathlon sometimes because they are very focused on their aerodynamics, that's normal. They want to save this second. So unfortunately, the wheels were only less than 1 second of difference. So in the Ironman Hawaii, for example, they are 130 kilometers, they are going to save 3 minutes only, and the difference on the price is irreal. So let's talk more material, more things that are interesting on cycling and cycling needs. A lot of people is very interested in carbon frames are the new religion on cycling. Fortunately, here in London, I was talking about that today. I come from one country where the carbon is everything. It's 99.9% of the market. So no iron, no titanium, no aluminium either. So everything is carbon. And in Italy too, I work a lot in Italy, and here maybe in the UK is a little bit different. I see titanium bicycles, iron bicycles, okay. At least there is something different. It's not everything exactly the same. Our monotheistic religion, non-come in Spain. The carbon is coming from the carbon fiber. This carbon fiber can be used for several things, aeroplanes, for cars, for a lot of things, sport things that they are not necessarily bicycles, there are a lot of things. It's coming from this material, the carbon fiber. The way of doing the carbon fiber at the start was, this is an iron bicycle that they put it on the looks exactly the same. And the way of introducing the carbon on the market was exactly making carbon tubes with joints and do this kind of bicycles that was the first available carbon bicycles of the history in the 86 on the Tour de France, made by Look, and TBT was the brand of the tubes. So it was the starting of the carbon era in cycling. The Mould system, that is aesthetically absolutely different compared with that, was starting on 92, and they made, instead of making the tubes, they make one piece only. The carbon was a monocask. Okay, in 92, this the bicycle of Chris Borman of the Olympic Games on 92 was an incredible revolution about the improvement. After 2 years, this was the bicycle of the hour record of Miguel Indurain in 94. This, I put it on this image to see, okay, this is starting the era of the monocask frames on carbon, but also for making a little bit of understanding how it works in the industry. After 2 years, it's exactly the same. So to invest in cycling and the new things in cycling that real works, and they are not very common. So to copy in the industry is quite common, probably much more than we can expect. Interesting, because in 92 there was only possibility of getting carbon with looks, with aluminium looks, where this bicycle that was the road bicycle of the Lotus One on the monocask. It came the change of the rules of the UCI. They banned this kind of bicycles, and they say the bicycle must have two triangles, the two diamond called frame, and they get 7 years for doing this, everything on carbon. Funny, because they were able 7 years before doing that, and after 7 years were able for doing that. So it looks like that they are going against the clock. But funny. So today's frames, carbon frames, are coming from this first one, 90, because the UCI decided to change the rules or not let the cyclists use those kind of bicycles. If not, probably today's bicycles look like this one. So one rule from the point of view of the competition can make the difference on the evolution of the material. Interesting for me. Today, this is the most used way of doing the frames, the molding. They put it on a mold, they put it on the carbon inside, they put it on the oven, and you take out the frame from the oven, as we see more or less on our bicycles. And another more traditional way of doing them, tube to tube, where the tubes are not with lugs, they are with resins and other carbon components. They make the joints between them. The fiber types are 12K, 3K, 1K, and unidirectional. This is the difference of the carbon that normally is used today in the industry for making the bicycles. Those are the cheapest one, those are the most expensive one. The difference in the proportion between the carbon and the resin, the strain direction of the control, the strain tension, and the flex mode. So the characteristic of each fiber is different. Sometimes they use only one kind of fiber, and several times they use different kind of fibers for doing that. That's the engineer makes the plan how to use the carbons, they put it on the mold, and it comes the frame as we know, plus frames that are here. From the point of view of the material, it's quite curious, because what carbon give us is basically a very big advantage from the point of view of the weight. But from the point of view, for example, of the resistance of the material to the impacts, classic crash, any cyclist has had a crash, is the worst material from the point of view of the construction. So if we want to have bicycles that they are quite durable and they are quite hard for using them in not very good environments, here in London, riding a bicycle, and they can come and crash because the cars and the traffic is crazy. So against the impact, the carbon is the worst material. So if the industry has decided to become a material that broke systematically, that's the conclusion of the story. From another point of view, okay, they got good characteristics, maybe the strength, maybe the against the corrosion. The titanium that is used, I see often here in the UK, is a more balanced material from the point of view of construction of the bicycle. Gives these characteristics in a very regular way. Only the weight is against the titanium, because it's hard to get in a very light frame of titanium, because the titanium is light but needs a lot of material for me do a stiff frame. But it's curious, because the industry today, 70, 80, 90% of the frames that are sold are carbon, although the characteristic of the material maybe are not the best one for the rider. Those are the fiber types that are used, and for example, we check the selling on a bicycle. I want to see and I want to know what are the characteristics from the point of view of the flexibility and from the point of view of the module. So there are different brands with different characteristics. Those are the most used one, the Toraica 1000 and the Toraica 800, the most used carbon for high level bicycles. And other bicycles are made with this kind of carbons that they are, from the point of view of the mechanical characteristic of the frame, absolutely different. Absolutely different. The characteristics are different. So this is the recommendation from the carbon manufacturer to say, use this carbon for doing that, doing this carbon for doing this other thing. Some tests made for different bicycles that probably you, some of them, BMC, Resmate, Scott Addict, Scott, Koga, Miata, Cervelo, Giant, Cervelo, Merida, so more selected frames, and the relation between the torsional stiffness and the torsional stiffness of the head tube and the bottom bracket. So the characteristic, final characteristic of the bikes. And there are several different characteristics. It depends on the brand, it depends on the model, it depends on everything. This information is not very variable for the public, unfortunately, and the public. That pays me a lot of attention. The public doesn't like to know this kind of data. They don't look for those data. So I have do my own calculus about this introduction of carbon and everything, and the use of the carbon in the industry, and I have taken some ranges that can be useful if you are going to get in a bicycle. If you want to know who is making the bicycle, who person, the face and name, probably you are going to spend 3,005, 7,000 pounds. It's impossible to know who is making the frame if it is cheaper. If you want to know who has designed, not made, designed the frame, you are going to pay 2,005, 3,000 around, more or less. For knowing the characteristic of the frame, minimum you have to spend 2,000, 2,005. The flexion and the torsion, that are the two variables, the most common variables used on the industry for maybe the classification of the frames. And if you spend 1.5 or 2,000 pounds, you know the composition of the frame. So that is carbon, carbon resin, carbon aluminium. So if you pay less than 1,500 pounds, you can know what is made of, any characteristic, neither who designed or buy your carbon frame. Okay, that's a limit. Let's change a little bit from the cycling industry to training, maybe something that can be useful for some of you. How much is expected to improve in a training plan, or how much improvement is necessary in a long-term planning for a competitive cycling? I suppose that some of you train, you got maybe also a trainer, a professional trainer that is giving some advices, training plans or something like that to become a better cyclist or doing the things in a proper way. To know if I am improving, and I am improving at the speed that is the logical speed, there are not several parameters that I can check. So I am improving, yeah, but I am improving more than if I did my training alone. I improve more slowly than expected. What's the relation? I'm improving. I'm really improving. That's the first question, should be. Okay, so some references that can be useful for you. 0.1, 0.2 watts per kilogram, that is the measure that we use for measuring the power related to our mass, the watts that are related to our mass, of improvement for a month in aerobic basic performance from the point of view of the aerobic resistance. That's that you have to improve every month if you are improving at the expected level. If you are improving less, it means that that training doesn't work for any reason. If we talk about anaerobic, about the sprint, about the acceleration power, a little bit less, from 0 to 0.1 of improving each month. This is an acute adaptation, means when I am training, I am improving. I less the training, stops the improve, and not only the improve, I became to the previous studying. Okay, that's an acute adaptation of the body. This is the same data made by another trainer and another physiologist that no relation, no direct relation with me and mean. So there are another data that goes in the same way, in the same proportion, more or less. If we check the categories of the cycling, we did some groups more than 25 years old, the professional riders, 24 years old, 23, and the juniors. We selected them and see, for going from 1 to 1, to say, okay, how can the junior go to the World Tour? Can we expect the improvement somehow, to have some expectative and say to the rider, yeah, you are going to be, or at least you got the enough potentiality of being world tour. It's not only the power, there are several things that can make, but what is true on cycling, if you don't got the engine here, you are not going to go here. So we need to need how much was the power of this engine when they were on those different categories. So every category, they need to improve 0.3 watts per kilogram from year to year. I mean, on training, you will improve. Once you left the training process for example, 1 month or wherever, you are returning to some previous situation. So this is not reversible over the time. That's what you win by cyclists, and you don't lose. And it's 1 year job, more or less. 0.3 in aerobic, resistant, endurance, and 0.2 of improvement in the anaerobic, sprint, the acceleration, and those are the reference to know that I am going at the speed that is needed to arrive to be a very high level, professional level rider. If I am going slower on this speed, I cannot be, because the time is going against me. I would not be a professional rider, never. The same data for given by Pinot. Another history, maybe for those that are involved in fitting, or they have come here to Cyclefit for a fitting, for example, this sounds somehow. The wedging and canting process in general, we are talking about the things that we put it on the feet to doing a better, a more straighter. There are several theories about the use of that, but we are talking about the things that they are between the, normally, between the foot and the shoe, and also between the cleat and the shoe. Things that change the angle of my feet over the pedal. That's the wedging or canting process. That's the way of, one of the way of measuring the angle of the foot in this position. And this is a retrospective view of the process. I come from today, where today I sell and I cant my clients sometimes. I teach another fitters how they should cant their clients, and Cyclefit do is more or less the same here. So we are not talking about one process that is very far from the bike fitting. Every bike fitter at the end is doing something similar. But I was very interested in knowing where is this science coming from. In 1997, it said by itself some studies about the foldable valgus and valgus, that is the angle of the foot, and it became the first worldwide seller of canting systems for a foot. 1997, on that year, became the eclosion, the revolution about the canting, the wedging and everything was available. Was also internet a lot of help, because we could buy those wedges by internet, mainly born maybe in the States. But maybe some casualty, I found that the Orthopodiatry Hospital of California 3 years before was talking, and this is the image, the original image of the advice, that they canted the foot to avoid the valgus process of the foot on 94. So it means that 3 years before somebody was talking about this before this other way. By casualty too, I find it that 2 years before there was one orthopodiatrist from the States that is quite famous, was making the recommendation of canting the foot on cycling because was related with the alignment of the foot, and maybe 2 years before. We are on 92 right now. And then I find it also by a little bit casualty, was not something that I was looking for. In the 86, one engineer was talking about the development of this is a mechanical point of view of one leg, how it works, how the canting should be made and it's talking about a little bit this condition is relatively rare among cyclists, but it will probably produce characteristic knee injuries if proper compensation are not made, correction of the forefoot valgus on 86, 11 years before that public said. So it means sometimes one can be or try to become in the starting idea of something, but maybe someone else has had same idea before than you, and you, maybe you are not the father of the son. So take care with these kind of things, because I think that some of us, we are very mythomanist, and we try to, no, this is the discovery of this process of this one. Science is quite complicated. To be the real responsible of very big change of something is quite complicated, only statistically. So normally what happens is that one improvement behind the other, and one discovered thing behind the other, and after the years it's coming the birth of the son. But the father was the father, the grandfather, the father of the grandfather, and you can go a lot of time before to find who was maybe the first responsible of that. That's, from my point of view, a very interesting thing and a very amazing process at the end. One of my favorites, because I'm somehow involved in that, was the way of measuring that is quite often, because it's quite public, and what happens normally that some of the feeders, a lot of feeders all over the world, they use this method to put it on the before and after position of the saddle. That's quite common. I was teaching on that, and I think that there is no feeder all over the world that has not been taught on how you do the knee over pedal spindle, the COPS method, to making the by feeding. So said by one by feeder and using the method, COPS use it, even though it has no real biomechanical basis, because it does seems to work quite well, and it's ideal start point when setting a bike up from nothing. One of the reasons that this works is really very simple. It works because it's simple. The science said that the change in the saddle head and before and after position of saddle doesn't make significant difference in the force expenditure. No significant differences. So it means that the method of measuring that has no relation with the effect of the results of the change. Maybe it's another thing, not that thing. That's a logical fallacy. But the same author, Bini, that is a high-level biomechanical authority on this book, that is quite a new book from the point of view of science. The upper body significantly changes in force and use of the muscle. So it's the upper body and mass what makes the change or the position of the cyclist, not the saddle. What makes the change really? This is totally understood. No, it's not totally understood. A lot of people doesn't understand that. Unfortunately, there is people that is teaching this and they don't understand what it is really. I don't know, maybe the original author at the end makes an explanation why they don't understand this. We are talking about the center of gravity that maybe is on this line. This is the gravity vector, more or less, on this part of the cycling. The original author of this said that we got what mass that make really the strength. All the other parts of the body, they are only transmitters of this strength, but the strength is coming from the center of the mass of our body. If we don't go mass, we cannot push the pedals. So this is the origin of the mass, and the origin has a center, like any other physics factor. The use of this center, the use of this point, is absolutely related with what is going to happen with the pedals from all the points of view. Doesn't matter if we are talking about disciplines and sport levels. The COPS started to fail because some new disciplines on cycling, mountain biking for example, and triathlon, didn't come on with the causality that was the COPS. So was no real basis to explaining nothing that was not explained because of the causality. So when it came people with different disciplines, new approach to the bike fitting on the bicycle, it coming a little bit of revolution. So here we can be in a very extreme situation, how the use of the mass become in a different cycling position, because if not, you cannot go on the uphill. So this rider is not a non-use, constant use of his gravity center, but it's the only way that he does for going uphill. This is exactly the same. This position is made because the gravity center goes in the direction on the pedals in some ways. You know, it's impossible to ride on this bicycle if the center of the mass is not in front of the pedal. It can be explained on the roll, it can be explained out of the saddle, stand up, seated. Physics has no exceptions, because the physics on this way, they are universal rules. So the universal rules, they are universal because there is no exception, no case that doesn't make sense. All the cases make sense. If not, they are not universal rules. And this is basic in Newton knowledge. So what happens that today we try to move the center of the mass in different disciplines. It depends what we are looking for from the point of view of the cycling. And we are talking about disciplines that has no very close relation between this. The Enduro, the MTB, the marathon, the cyclocross, the road, the medium and long distance triathlon, the short distance triathlon, and the time trial, or maybe also the track. So everything can be explained with everything. If not, there is not an universal law after this. So the approach makes sense with all the explanation of the needs of the force and the acceleration at the cadence and the speed of the riders that go on different way of cycling. Explains everything, every case. Makes sense from the point of view of the mistakes that can be having done on the fitting process. The inventor, or maybe the first that was involved on that and tried to explain this concept on the late 80s, that was Haven Trower. Unfortunately, it's not known because of this. It's known by another reasons that probably are very public reasons. But from my point of view, from the aesthetic point of view, it's very important from this explanation. The explanation that he gives in 98 makes him know to people like me, because in 98 I was not able to understand this, why the people was not going to understand what was going to happen on the filter. But it's incredible, because, okay, explain this, makes sense, and nobody's going to understand this. So like the, more or less, like the explanation of no, doesn't matter, nothing, no examples. Okay, so this explanation will never be a commercial valuable fitting technique. It's too complicated. So it's a word. Simple methods like the traditional ones will be more useful. It's said in the 98. It's incredible. For me, it's incredible because he is explaining 20 years before what is happening today. But the people doesn't understand this. So for me, a visionaire. He's the knob, the angle is exactly the same, the upper body changes, and in the knee doesn't happen something. Pedaling technique. This story starts on the late 80s. This is Cabana, probably the most evaluated biomechanic in cycling on the starting era. Today is quite old. I don't think that he's working on research, but in the 80s and the 90s he published a lot of works. We can say he was an advisor of the youth Olympic team for the Olympic Games, and in 88 we can say categorically that the claims of some about pulling up from the pedals, pedaling technique, that was his famous diagram, increasing performance is waiting for a cycling is invalid. So pull up from the pedals 88 doesn't make sense, doesn't work. Say by a quite well formed and quite respected professional on biomechanics. 88. Today, you are going to the internet and you put it on pedaling technique because you want to improve and you want to know what's going on about pedaling technique. And you find this kind of very interesting methods of explaining how to pull up from the pedals. It's quite common. Pedaling technique, you are going to find these kind of things, pedaling circles. The poor technique wastes energy because you are pushing but you are not pulling. You have to forward, downward, backward, upward, and this is the right pedaling. Lift up, downstroke, set up, pull back like the clock. I don't know, there are several explanations. And the consequence of that, there are some trainers that take the information and say to the rider, we have to improve the pedaling technique. So take out one of your foot and go pedaling only with one leg to pull up from the pedals in a real situation. Obviously, if you take out the shoe from the pedal, you have to pull up because if not, the pedal stops. So this is a very common training system advised by a lot of trainers today, and it's available on internet, so you can find it easily. I remember 88, no, doesn't work today. That. During this time, the science has tried to say to the people, if you pull for the pedals, there is more energy cost. If you pull up from the pedals, the muscular equipment is more complex. Different authors, different approach, everything on science saying, don't pull up from the pedals. But this is the reality. People want to believe, and as at the start of the conference was, well, people believe in weird things, in these things. The science says no, why they do on this way? Okay. Sometimes they need to have examples, information to say, okay, I will demonstrate you that in your case doesn't work. This is one system that is available today to see how we pedal with each leg, and we make the strength over the pedaling to say, okay, I'm different from the others maybe? No, probably you are not. But let's check your data and make an individual interpretation of you. And this is one professional rider that makes 92 revolutions per minute. This battage that is quite high. Not a lot of people is able to do that in a sustained situation. One leg and another leg, they do normally with one leg what we do with two at the same time. So they are professional, we are not. And we see that for doing that, they don't pull up from the pedals. Those riders, completely, this rider has been top 10 on the Tour de France, winner of 7 races and everything. Maybe he's a mistake. You cannot do a mistake, a very big mistake, pedal on this way and try to win in the races. No, the differences are minimum. So he doesn't pull up from the pedals. The professional rider doesn't pull up from the pedals. So I don't know why people is going on trying to pull out from the pedals and doing the wrong pedaling and these kind of things that really I cannot understand. What happens, that is quite funny thing, is that we overuse the radial force of the pedaling. I will try to explain, it's not an easy concept, but I think that I will be able to make you know what happens. When we are pedaling, there are basically 3 forces. We are going to delete one for the analysis for being easy. One is going, you run downstroke against the crank some strength, and in this direction another one. What that you're doing is that this composition of this strength. One is the radial, and this is the tangential, a physics process that allows me to do. And we got the possibility of measuring this force. It's funny because the strength that's made tangentially is what makes the movement of the pedals. It's the good strength, the strength that goes to the point. This other one is wasted. We cannot do nothing against the crank. We cannot compress, we cannot extend, not normally. So it's wasted strength. You do the strength, but this strength is not going any kind of movement. This rider, this professional rider, is doing as much as strength on the radial, the right and the left, as in the tangential. He's losing a lot of energy because his technique is not good. This is physics, and we have to improve the system from the point of view of the knowledge, and we got the perfect tool for try to improve and explain to this rider, look, that you cannot do nothing against the crank, it's so rigid, and the movement is coming here, it's not coming here, so we are going to change something to try to give him more energy here. Here we can see the difference between two riders, very good riders. Those are very good examples. I mean, they are not trainers, they are not trainings, they are races and maximal intensity races. You can see on the amount of newtons that they move on the pedals. They are pedaling very strong. One of them is making 250. The other one is less 250. Happens the same on the other sense. One uses less the radial force and the other one uses more the radial force. Wasted energy at the end. One on the direction is exactly the same. They do the same strength for moving, but one is wasting energy and the other one is not wasting as much energy as the other one. What is happening here? Take a look also of the acceleration that comes here, for example, in 60 degrees, this amount versus this amount. Less energy here, more energy here. More energy here, less energy here. So the wasted energy not only is wasted, it's going against the good energy and the good sense of the force. So you are fighting against the bicycle, not providing more speed to the bicycle. In general, related with this, we have discovered that the gluteus is quite funny muscle that during the cycling, some of the riders, they use them, and some of the riders, they don't use them. The gluteus is the muscle that is here. When there's a partial squat, means when you make a small flexion, that is the same exercise as in cycling, you use a 20%. The parallel squat means that you put it on the knees and the hip at the same one, using a little bit more. And only when you are going down, really down, you are going to use the gluteus in a significant way. So it's quite difficult to use the gluteus when you are doing your pedaling. What's the matter? When I cannot use the muscles of the gluteus, my acceleration is not very good and I have to waste my energy against the cranks. That's the end of the story. But there is scientific evidence about this? No, it's my only personal suspect. And I have to make you know what is science, what's my opinion, to make the difference between the one and the other. I have to do my explanation about the data that I got, but it doesn't make, this is not going to make science, not yet, it's not prepared. Probably you are convinced that I can change it and I control the system because I am looks like I know a lot about this, but I have no evidence about this, it's only anecdotal data. So, T.X. Huxley said, the great tragedy of science is that slaying of a beautiful hypothesis by an ugly fact. That's what happens sometimes. It seems that we are going to know nothing, but it's coming the fact, and happens the opposite one. So it's not funny for research people, but this is what we got. Thanks in my language, Scarricascopa's language, and lost. If there is any question, we have taken a lot of different issues in several things, so I suppose that.
Yeah, you had the slide where you was comparing two wheels. You said there was a 1 second saving from the Millensteins to like a standard robot,
Maximum.
is that aerodynamic or is that including the weight of the wheel? So what is the performance benefit?
Aerodynamic. Aerodynamic. We are on a flat situation, 40 kilometers per hour, same bicycle.
Okay.
We are not involved in mass, nothing else. But it has no relation to the mass, because one, you are, that's the first law of Newton. When you are on 40 kilometers per hour, the mass, if there is no acceleration, the acceleration doesn't matter.
Okay. So the weight of the wheel is not an impact?
Full aerodynamic.
Okay.
Try to sell wheels here, telling you are going to, to save 1 second per kilometer, buying this incredible. You cannot use this kind of data because science goes normally against the marketing, or maybe it's the other thing. The market is going against the science. So,
and it depends if you've lost the race by a second or not, though, doesn't it?
tell me again.
If you've lost the race by a second, you probably pay the extra money for the faster wheels.
Probably, but who is going to lose the race is not going to pay for the wheels. Yes or no? That's the difference.
True.
Can you tell us about the sheep? Because I only saw the photo.
Well, it's under a confidentiality contract. I cannot tell about.
What with the sheep?
Can I tell something?
There's legal proceedings following, isn't there, from the sheep, so we have to be a bit careful. You can't really speak of it, John.
Do you know that there is
There are some issues outstanding with that.
Yeah. It's one thing that will probably become a revolution of feeding on the future.
What's your theory with your last set of slides with the crank tangential power and
the length of the punch?
Like what's your theory about how do I get a bit faster?
You have to come to the symposium every Thursday because it's said on the first time here, field board said the length of the crank, not said by him, he was relating the research of Jim Martin, that is probably the biggest international authority because he has done a lot of research. The length of the crank doesn't matter from the point of view of giving more power. You can have exactly, believe me, because it's what science says, not what I say, the same power, 165 and 185. We're talking about 2 centimeters difference, so it's quite different. But I feel the difference, what the cyclists say normally. We are talking about the power in general. You can have exactly, or you can push the pedal with the same power. The way of getting this power is different. One is based more on the strength, the other is more based on the currents. But the power, from the point of view of the performance, the difference that should be shown, and normally people, when it comes to feeder, what is my size? And you got another one. They don't want to tell. They don't want to know about the truth of this story because it's not funny. That's a logical fallacy, because the logical fallacy what makes is a good story with a good ending, and the science comes to telling things that they are not very funny. And it cannot be famous, this story, because how can it be the same? Yeah, it's the same. It's what science says. But I want to believe that it gives me more power. That's another thing. You want to believe, yeah, true.
I changed mine to give me less injuries.
About the injuries is not a lot of research, but what happens is what we know that is not so much about that. The longer, the bigger possibility, because the room of the movement that you are using is more, so the less. What people want to tell you when it's coming to my fitting, and I suppose in Cyclefit it will not be different from my business, is tell me please that I will get more power using longer cranks. That's what I want to say. But that's not true. That's what he wants to change, and he wants to, he wants and believes. And
Jim Martin's data that he produced at the last symposium actually said there was no peak power difference between a 120 crank and a 220 crank.
Yeah, I have put it on some reasonable measures, but they are much more wider,
So
difference.
peak power didn't change between 120 and 220.
The acceleration.
Acceleration, so
The acceleration change.
The torque change,
Yeah.
but the peak power doesn't.
But the peak power is exactly the same. So you arrive to the same point by two different ways.
Yeah.
What about this oval crank rings. What do you think about those?
What science says today, in the acceleration processes, I mean, you start from 0 kilometers and you go to 20 to try to accelerate the bicycle, seems that they somehow make a benefit. Once there is no change in the speed, they don't work. They don't any kind of advantage, nothing like that. It's not clear. It's not clear because we need probably more research about that, because there is one very funny story. They put in one research, experienced oval chain ring users, experience it, they know what they are doing, and they put it on one box to know what they were using, only to know, because they were experienced it, and say, no, I feel the difference. You feel the difference. No. What is this? The oximetric? Yeah, was not. What is this? The rotor was the normal one. Only the 30% of the asks were right. So it means that the experienced users of oval chain rings were not able to know where we're riding. That's a feeling of the human body. Imagine.
John, hi. If you could just repeat your... Sorry, I got a crooked thread, so I put it down the train.
That's not.
Just repeat your hypothesis at the end there around the difference in the pedaling technique with the contribution of the gluteals in the pedal stroke. What was your hypothesis? Just repeat that again.
The only thing that I can tell is that we are very focused in trying to measure and make some exportable knowledge, because today is not packaged, the knowledge, to make understand to the people that they have to use the gluteus when they are pedaling. It's very difficult because it's not a tonic muscle, so what happens that it's not easy to try to program it, because it's the brain that say use, not use. So it's not as easy and say, okay, use this muscle. It's much more complicated than that, because it's a tonic muscles.
Because of what muscles?
Tonic or phasic muscles. They are phasic, yeah, and or tonic. So it's much more complicated to control some of the muscles than the other ones. They are.
Why is that?
Because the activation of the muscle, neuromuscular activation, is different.
Of the gluteus?
In this case of the gluteus.
Why?
Yeah. Because they are positional. The posture muscles, we control them in a very inconstant way. I am not thinking on being standing, but some of my muscles are working. But I don't feel that I am sending the signal to them. You feel that you are sending signals to your muscles?
Yeah, always.
Go on with the story, please.
You know
what I mean. Yeah. So this is the difference. And there are other muscles that they need a straight signal to say, okay, flex the knees and do the movement, but there are several. So what happens? That the gluteus is very difficult to activate because his characteristic. In our posture, unfortunately, the gluteus are not very used. We have changed our pattern. Probably we have got a change in our Baricenter. We are standing up, and this has become in this problem. Our sedentary way of living, our use of the shoes from starting ages, a lot of things maybe are related with this, but that's not science. That's my maybe hypothesis.
But this gentleman's question, I think what he was trying to ask is how would you, if you were going to try and introduce more gluteal contribution when you're cycling, what things would you do to do that?
I don't know. That's true. I try to do my best for using them. I am very convinced about that, because I somehow got information for becoming in a better pedaling pattern, because I know what I have to do, so nobody has to tell me how to pedal, because I know how I should pedal. I'm not able to control the gluteus for a long time. So I try to use them, I use them, but somehow I cannot go on using them. They are not especially tired.
I cannot control them. That's all.
The data you showed at the end, the last slide I think it was, where you went from a high squat to a partial squat to a full squat. At the full squat, actually, you got the greater activation, 47%.
Yeah.
So, you know, what I think you were getting on to some sort of observation there about
the characteristic of the good pedaling is that from the start of pedaling, you are making a lot of strength. The acceleration is strong from the start. Because you go to the end, the radial force is going to eat you everything. You are doing the same effort muscularly, but it's not going to the ground. The only way of going to the ground is to accelerate from the start. That's a good pattern for the pedaling. It's quite complicated to understand. Okay, if I got no strength here because I cannot use the muscle of the gluteus, what is going to happen that my nerves is going to do the job and I'm going to accelerate when it's arriving 90 degrees of the crank. That is quite easy. It's what a lot of cyclists does and pedal in the second part of the downstroke. But that's not a very good news because they are losing a lot of energy against the radial force. So for not losing that, what we should do is to try to accelerate from the top dead center to the 90 degrees. For that, we need the gluteus. But the gluteus is not activated in some cases. It depends. There are people that they use the gluteus quite good. But if you ask me for what is good of using, I cannot answer. I have no reference. We are looking a little bit what can happen, how we can improve. We got no diagnostic, so we cannot think on the solution of the problem because the diagnostic is not quite clear. Everything is based in hypotheses and based in ideas that sometimes they become illogical fallacies. I think that should be that, but the facts say that not. So I have to study again and find what is the key of the problem. So probably we are talking about a long evolution of this knowledge because actually we got not a lot of information about this.
John, in terms of this glute activation, is there been any research done in terms of measuring that on the bike? I'm thinking specifically about the difference between a track cyclist and a road cyclist. If you look at the amount of gym work and so many things like back squats a track cyclist would do versus a road cyclist.
Research, formal research, no. Maybe some experiences and some facts that maybe can take you to this knowledge. Track riders, sprint riders, they got on the track. You can see that they got big muscles.
Yeah.
They use a lot of squat from behind for being stronger. And if they have not strong muscles, they cannot pedal.
There's no research currently about
No research, formal research, no. Maybe there are some facts that go with my proposed theory or my proposed hypothesis that has to become in a theory. But I see that the solution maybe is too far really, because we need a lot of things to do to see that, and sometimes there is no possibility of going on with the research. The research is a very complicated world, so that's what's happened. But everything is going to the same direction, and a lot of people, not me only, around the world is looking for that. Cyclefit, and I think that we got the same obsession with the use of the gluteus. Maybe from an empiric approach, my approach is more from the research, but everybody is looking for the same point. Nobody knows how to start working. Maybe someday by causality somebody can imagine something about that, but I cannot see a very close solution in the time. It will be complicated to find a solution. Okay. For sure.
Could you tell us more about your saddles, John, please, and the science behind them?
My saddles.
The shark saddle angel.
Yeah, the shark.
There is one shark here.
Yeah, just under the counter, John.
Rats in brown paper. Play.
Well, I think that was
They're just at the bottom of the saddle rack.
Sorry, it was on the border, it was black. So this is the shark, the original one. it's not very useful.
That's why I'm asking these questions.
There's a surprise.
No, it's quite easy. Our hip has 3 points of contact with the saddle mainly. The four part of the saddle and the ischions that they are here. This part of the saddle is using one space where there is nothing really. It seems that something is here, there is nothing here. This gives some kinetic signal to the end of our spina to know if we are straight or we are twisted. If you twist over this saddle, it's going to not make pain, because the most surprising thing of this saddle, that when people start to ride it, doesn't make pain. How is it going to make pain? You think that somebody is going to invent something to make pain directly to the customer? Doesn't make sense. So doesn't make sense. It's only a guide, a corrector to try to the people that is not able for being stable, for example, or maybe to be straight over the bicycle, is a tool. It's not a good solution for the rider that wants to try it, because it's quite difficult to put it on the proper way, and the rotation of the pelvis is not only related with the saddle, it's also related with another factor. So it's not a saddle that should be sold in any shops, because maybe it cannot be dangerous, but it's not good for the saddle too, because it must be used by professionals of the bike fitting, that they could understand if it is working, if it is not working, it's going to make pain, it's a good solution. It's not the only solution. Since 95% of the people doesn't know that it's not straight on the saddle. So it looks like the perfect solution for all of these people. My idea of the start was not that, to trying to be the saddle of the future and became all the other saddles. No, it was not the idea. A lot of people can ride in a normal saddle without this. This is only a help that can be used by people that doesn't know to sit over the saddle. For example, yesterday we had one case in Italy. Yeah, yesterday. Was yesterday? How was the name of the guy in Italy? Danilo. Yeah. One rider was absolutely twisted over the saddle, and we were changing things for the pedaling, for the shoes and everything, but he had a structural matter. He didn't know how to sit over the saddle. It was twisted, everything changing. At the end he was straight, but it's one probably, when you got a structural torsion of the pelvis and you are twisted the whole life, not only of the bicycle, this can help you, became in a help maybe, for teaching you what it's to go straight. Because the most of the people, before doing this kind of things, the most of the people that will come to us, they said, okay, this is straight. No, cannot be. And they followed, this is straight. So it became in a stupid conversation, because when he was twisted, he said there was straight, and he was straight, he said we was twisted. So we did, okay, we have to change the rules of the game, because this is not going to work so far. So we invented some things, and today this signal, they are in different sizes. It's people that only needs a little bit of size here to know what is this twist, and this is the M or the L1 model. So the fin of the shark sometimes is bigger, sometimes is a little bit smaller. It depends on the use of the fitter, and it depends on the rider. That's more or less the story.
And why is it important that they sit straight on the saddle?
That's a very good question. Be straight on the saddle means be straight on the bicycle. And the bicycle is symmetric. And you need symmetric holds on your hands, symmetric holds on your feet, and symmetric hold on your pelvis. So there is no possibility of going asymmetrically on the bicycle and not get pain, because it means that with time some structures that we are going to make adaptation in different ways. So maybe this knee is working more than the other one, maybe this part of the skin is hurting me because it's burned and this other one is on the air. Maybe my neck is, as I am twisted, working in one side and the other one is not working. So the asymmetry is pathology from the start. So go straight on the bicycle is key for trying to avoiding any kind of problems. If you are going twisted, if you see the bicycle from one side, for example, and not for the other side, if you feel that the knees are not working in parallel, you probably are going twisted over the saddle and your tilt is not symmetric. And that's a problem, one problem behind the other. Cannot be asymmetric, the bicycle, because it's symmetric, the bicycle.
Can you use that saddle as a training aid and revert back to a different saddle, or can you train yourself to sit on the saddle properly?
Yeah, it's possible. We have seen several cases where people, they try to take off because they want to try if they are able for sitting, and some of them, they go straight and they have learned to, and other ones, they have take off, they twist it again, and they have to use again. Because having no statistical data, we have seen both cases. So probably it depends of a lot of factors. You have to go in on using, maybe for months, maybe for the whole life, I don't know. Or maybe you can use for some time, and then your structure has been more symmetrical. You have somehow learned to sit off the bicycle, and you put it on your normal saddle, and you can go straight. But I think that it will be a very individual adaptation to that.
Winston's shark office chair coming out. Shark sofa.
And?
Shark sofa.
I don't know really. We have tried to do very different things. The most funny thing of this is the asymmetry during the day-to-day when you are standing up and you are twisted on the office, when you are walking or whatever. It's pathologic, but it's not as visible on the bicycle. In the bicycle, change everything on the saddle because the pelvis is limited on the movement. So when you are asymmetric on your life and you are twisted, the incoming of the problems normally is not as evident as in the bicycle. But to have fixed the pelvic, change all the rules of the game, and this cannot be twisted and fixed, because twisted and not fixed, you can compensate the human body is a great compensator of everything that when you are fixed on the pedals, fixed from the point of view of the gravity of the pedal, over the saddle, sorry, and over the handlebar, no freedom for movement. So the asymmetry is much more public than in the normal. So I don't know. I will try to use very carefully this solution for the bicycle, and the rest of the problems probably another one can help you on your problem out of the saddle. No.
Okay, we have questions.
No.
So, John, I want to say thank you. Thank you for coming. Okay, so next time it's...
2 weeks time,
2
it's
weeks.
Cycling Power Lab, 4th of March, and then on the 26th of March we've got Mick Hadgood talking about cyclist foot, that'll be important one, then 16th of April we've got Taylor Insurance.
Okay. Thank you, Simon. And thank you, John. Just to say, when we run the symposium every year, we always try and get speakers to be brave, and we always try and ask them to... Considering fitting is the Wild West, you'd think that people would be brave to come along with their theories, but what tends to happen is people tend to sit in their bunkers, develop their crazy theories, and then are too scared to come along and present them to the symposium. And the reason we love John so much is two reasons. One is because he's absolutely brave enough, and secondly, his crazy theories generally turn out to be right in the long run. He's truly a disruptive thinker when it comes to fitting and sports science, and he's not a gruffalo, he's not someone who's stuck in a bunker developing his crazy theories. He's somebody who is actually developing theories based on his scientific training and scientific ethos, which is as a pedigree scientist, and he presents them in a way which are both disruptive and fun to the audience. So in that respect, he's a class of one, and also he's not scared to come along and speak in a language which is not his own, which is actually quite a scary thing to do. So thank you again, John.